This is the first module of the second unit. This is module 5. What does it say? There's unit 1, module 4. I'm going to go back to module 4, but this is unit 2, module 5, which is quadratic. I think it's quadratic relations, isn't it? It is modeling quadratic functions. Ready? Okay, we're ready? Okay. So in grade 9, the main function that you're dealing with is always a linear function. So lines on a Cartesian plane are linear functions. Remember that a function is a relationship between an x and a y. The x is the independent variable, and the y is the dependent variable. So for example, if I gave you something like this, and I said, this is the cost, and this is the number of games bowled at a bowling alley, where do you find your independent variable, and where do you find your dependent variable? Where is your independent variable? Okay. Does the cost depend on the number of games that you bowl, or does the number of games that you bowl depend on the cost? Yes?
The number of games you bowl depends, the cost depends on the number.
Yeah. How much you end up having to pay depends on the number of games that you bowl. So this is where the dependent variable is found, and this is where the independent variable is found. Okay? So this is the first thing you'll write. A function is a relationship between an independent variable x and a dependent variable y. Okay? For now, you can call this a function slash relation if you want. If you So linear function from grade 9, draw this. So linear functions are lines on a Cartesian plane. You don't have to write that. There is a general equation that we use to represent this function. Okay? So functions can be expressed on graphs. They can also be expressed as equations. If this was c and this was n, okay, the general form is y is equal to mx plus b for a line, right? Do you remember that? But in this case, the y is what letter? What letter are we using instead of y? Jules? Yeah, what letter am I using? Yes. And instead of x, Maya, what am I using? Yeah. Okay. But what does this m and this b stand for? What is this and what is this? Yeah. Yeah. This is your slope and this is your y-intercept. So this is your slope and this is your y-intercept. Now, what does the y-intercept mean? What is a y-intercept? Yeah. It's where it crosses the y-axis. Katie, where does the function cross the y-axis here? Which one's the y? The up and down one or the left and right? Where does it cross the y-axis? Yes. So that's your y-intercept. So we have a plus 3 here. Then your slope, what's the formula to calculate slope? Nick? What is it? Yes, that's what I want. Yeah. It's how much you rise over how much you run. So let's take this ordered pair, and then let's take this ordered pair. How much do you rise here? And how much do you run? So it's 1 over 1. So your formula for this is n plus 3. So we can express functions as either graphs or equations. Both are very, very useful. Okay? Sometimes you can look at a graph and just tell things like, oh, it's increasing. Where this is a little bit harder to tell that it's increasing. So sometimes there are benefits to having graphs, and sometimes there's benefits to having equations. This only goes up 4 games, or 5 games, or 6 games. But what if I want it for 20 games? Where would I put the 20 in? Yeah, you would put the 20 in for here. So then I don't need a graph because I can just use the equation to figure out what my C value is way down the line. So do you see that there's benefits to both having graphs and to having equations? Okay? There's also significance to things. Like you should understand what both of them mean in the real life context. So what do you think the 1 means and what do you think the 3 means in this case? So you go to a bowling alley. And how many games do you bowl here at this ordered pair? Like this is the order, what's this ordered pair here?
0.
Yeah, that ordered pair here is 0, 3. Meaning that the n is what? Is the n the 0 or is the n the 3? It is 0 because isn't it the x? Isn't the x come first? And then what's the y? Or what's the c? It's 3. So what do you think that is?
It's the starting rate.
Right. It's the initial value. What do you think in the real life context of going bowling, what do you think that is? What do you think that cost is of $3? It's the shoe rental. Because you have to go there and you have to pay for a shoe rental. So even if you bowl 0 games, you have to pay $3, right? So that would be, the purpose of B equal to 3 is the shoe rental. The purpose of M equal to 1. Every time you go 1, it goes up 1. What do you think that means? Idea? Yes, exactly. It's the cost per game. It costs $1 per game. Now, if another place, maybe another place chooses $3 for their shoe rental, but they charge $2 per game. then that means the slope is 2. So it would go up 2 and right 1. Oops, sorry. Up 2, right 1. Up 2, right 1. So the slope would be more like this. You'd have a steeper slope. Okay? Maybe they don't charge. Maybe the $2 place doesn't charge for shoes. In that case, you would start here. Go up 2 and right 1. Go up 2 and right 1. So you get a function like that. The important thing is that we use math in real life situations to be able to get data points, to get all these ordered pairs, and they all have significance in like the word problem. That y-intercept 0, 3 doesn't mean nothing. It does have some significance. It's shoe rental. That slope of 1 means something. Okay? So that's linear functions. That's what you tackle in grade 9. In grade 10, you started to look at quadratic functions. So quadratic functions are, so a quadratic function, this is the short symbol for function. A quadratic function is a parabola on a Cartesian plane, where those were lines on a Cartesian plane. Everybody have this? Can I erase it? Call this 1. We'll call this one 2. And then we'll call this one 3. Okay. So again, for real life situations, sometimes there's a quadratic relationship. It means that the x has a 2 on it, has an exponent of 2 on it. Okay? But I'll go into that in a little bit. We can express any function in the 2 main ways, which is as a graph or as an equation. Right now, let's tackle graphs. Then we'll go into equations. Okay? So for these graphs, for parabolas, there are significant properties about these graphs. The 2 most important properties of a graph about a parabola, can you name one of them? What's the most important point on a parabola? Yes, it's the vertex. So that's this point, where it changes from increasing to decreasing or decreasing to increasing. So the vertex is the most important point. The next most important points, okay, are the intercepts. The x and the y-intercept. Really important, though, is the x-intercept. There are other things that you used to tell me, though, about this stuff. Okay. Can you think of what you used to tell me? Yes. Not for a what's it called? Not for a parabola. Yes. Max and min is, I'll skip that one. I'll move it a little bit down. Okay. Yes. Yeah, what does that tell you? Yes, direction of opening. Where the parabola opens is important. So the third one. Okay. The third one is called the axis of symmetry. It's the line that divides this parabola, which is symmetrical, in half. The important one is of symmetry. So you're getting a little taste of university. Whereas university, it's like in high school, you have a structured note. Basically, the teacher has like, oh, write this, then example, then write this. There's like a flow to it, right? That's just completely straight down always. A lecture is often, you kind of jump all over the place and you talk about the topic, and you got to do your best to make notes out of what he's saying. And so oftentimes you need to rewrite the notes in university to make it more clear and cohesive for yourself. But this is kind of what university is like. Okay? These are the 5 most important properties of parabola. There are other things like domain and range. Okay? We'll do those too. Okay? There's other ones too, like a y-intercept is important, but we're going to stick to these 7 to do for these. Okay? All right. Jules, you want to start? So for parabola 1, what does it look like the vertex is? 1, 1 is this point here. Negative 1, 1 is this point. Take your time, okay? Take a second. This is your origin, so how do I get to the vertex? Take your time. Negative 2, 1 would be here and then here. But where's your vertex? Here.
Negative 3 and 1.
Right, because you go 1, 2, 3, and then up 1, right? So your vertex for this is negative 3, 1. Katie, what are your x-intercepts? X-intercepts, what would you define x-intercepts to be? Yeah, where it crosses the x-axis. Very good. Yes, we're going to give them as ordered pairs. So this is negative 2. What's the y value on that? Right. Negative 2, 0, and 4, 0. Very good. Okay. Nick, you get the easy one this time around. What's the direction of opening on this? Down. Very good. Maya. The max or min value. Does it have a max or does it have a min? Yeah, it has a max value because it has a highest point. This keeps on going down and down and down, right? So it has a highest point, not a lowest point. Okay? So this max value, what you do is you tell me how high it goes. When you tell me how high it goes, you're telling me on the y-axis, how high does it go? So Maya, what's the max value? You go max value of what? What's the highest it goes? Yeah, but you don't want to tell me left and right. You want to tell me up and down how high it goes. So what's the highest that it goes up and down? What's the highest? Yes. Okay? So the max value of 1. You're with me, Nick? Okay, the next is the axis of symmetry. The axis of symmetry is a line that divides this in half. Now, is that a vertical line or a horizontal line, Jules? Yeah, it's a vertical line. Does it cross the x-axis or does it cross the y, that vertical line? Yeah. So vertical lines are always written as x is equal to, and what is the x value that it crosses through? Careful. 3 is where? No. 3 is over there.
Negative 3.
Yes. Okay? So your axis of symmetry is x is equal to negative 3. Now we'll get into the, actually we'll come back to domain and range for the 2 of them, okay? Or for the 3 of them. So Nick, you're next. For 2, what is your vertex? It is 4, 0. Very, very good. Lost what I was looking at there. Maya, what's your x-intercepts? It's where it crosses the x-axis. But cross can mean touch. Yeah. It only has one x-intercept in this case. That happens sometimes. Parabolas can only cross once. They can just touch the x-axis once. So 4, 0 is not only our vertex, it's also our x-intercept. Okay. The direction of opening on this. So Jules, you get that one. Yes, it's also down. What is your, does it have a max or does it have a min, Katie? Yeah, it has a max. What's the highest value that the function goes to?
4.
Careful. 4 is left and right. I want to know how high it gets. No, Nick. Sorry? Yes, it's 0. So you say a max value of 0. Okay? You get, okay. The axis of symmetry is the line that divides the parabola in half. What's that line? Yes, but you cannot write 4. If you write 4 on your test, you do not get the mark. You have to write x is equal to 4. Please tell yourself that on your page. You have to write x is equal to 4, or you will not get the mark. And it comes up all the time. Okay? All right. Finally, number 3, Maya, give me the vertex on that.
2.
Good. Jules, give me the x-intercepts on that. Tricky one. Yes, there are none. So what you write is none. Okay. Katie, give me the direction of opening on this one. Yeah, it's up. Nick, what's the max or min value? Does it have a max or does it have a min? Yeah, it has a min. A min value of? Very good. It's how low it goes. Not because of 2 this way, because of 2 this way. And then your axis of symmetry, Maya.
2.
Thank you. X equals 2. Okay. All right. Domain and range. Domain is the set of x values that your parabola will hit. The range is the set of y values that your parabola hits. Okay. So, what you do to figure out the domain is, this is like one of the harder things in grade 11. You're going to have to do it a lot in Unit 3. So let's start to get at it now. What you do is you walk along the x-axis. So think about for this parabola. Is there anywhere you would not see the function? So like if I'm here, would I see the function? Yeah, you could look up and see it. If I was here, could you see the function? You can see the function because you're right on top of it. Okay? If you're here, could you see the function? Yeah. You would look down and you'd still be able to see it. If you were here, would you be able to see the function? Yes, because it actually keeps on going. So eventually it would come out still, and you'd be able to see it. It's really far down, but it's there. Okay? So what we do is we're going to say that no matter where I am on the x-axis, because even if I'm here, if I look down far enough, I'm going to see the function. We say x belongs to the set of real numbers. So that here, that's an epsilon. It's like a little c with a stick in the middle. Okay? It means belongs to in math. And this double r is a real number symbol. That means that it can take on 1, it can take on 1.5, it can even take on 1.12. It takes on all the numbers, all the tiny little numbers, in between all the bigger numbers, like the whole numbers. Okay? All right. So that's x belongs to a set of real numbers. But let's talk about the range now. If I had done, Nick, you're with me, eh? If you're doing the range, what you do is you ride an elevator. Instead of taking a walk on the x-axis, the range is for the y's. So you ride an elevator on the y-axis, and you tell me where you would see the function. So you look out the window and see if you would see the function. Down here, would I be able to look out and see the function? If I'm down here, would you be able to look out and see the function? Yes. If I'm down here, would I be able to look out and see the function? Yeah, because it'd still be here, right? If I'm here, would I be able to look out and see the function? Yes. If I'm here, would I be able to see the function? Yes. If I'm here, would I be able to see the function? No, because you can only look out the window here and you wouldn't see any. Does that make sense? Yeah? Okay. Usually you agree, so you're not agreeing, so that's why I don't feel comfortable. So you only see the function on what floor and below that floor? What's the floor that you stop seeing the function at? What floor? Which floor? Like 7, 3, -2, 0. Careful. 1. It's on the first floor that you stop seeing the function. Everywhere below the first floor you would see it, but not anywhere above 1. Because even if you're on 2, you would not see the function anywhere out the window. Does that make sense? So the range is, what you do is you write y belongs to the set of real numbers such that stick there is such that y has to be less than or equal to 1. All the y values that the parabola will take on needs to be below 1. How do you know that this means less than? It looks like an L. Less than looks like an L, greater than does not. Yes?
Do you have to do the brackets?
Yes. Set brackets? Yes.
What do they mean?
They mean it's of. So it's the set of real numbers, or it's the set of these values. Okay? All right. So, for the blue function, if I walk along the x-axis, is there anywhere in the function that you would not see the graph? So take a walk along the x-axis. Is there anywhere you wouldn't see the graph? That's right. You would always see the graph. So in that case, it belongs to the set of numbers. Graph as well. Parabola is the easy mark. It's y belongs to the set of real numbers. It's the range that you really have to think about. Because the function has a max or a min value, like look at this is the max value, right? That means it's the highest it goes. Jules, pay attention with me for a second. So the max, this has a max value of 1. That's why all the values have to be below 1, because that's the highest. What do you think the range would be on this one? Does it have a max or a min? Yeah, it has a max of what? Right, so the 0 is the highest that would go. What do you think that the range would be? Well, you have to, I'll start you off. You have to write what? Belongs to the set of real numbers, yeah. Such that, what do you think it means? Yes, you say y is less than or equal to 0. Because you can be 0 and you can be everything below it. Now, Katie, the range is going to be a little bit different here because it has a what? It has a min value, meaning that all the numbers are, yeah, they're above it. So what do you think the range will be? Well, what's the full thing you're going to write for me here? Y belongs to the set of real numbers such that y is not equal to 2. What symbol are you going to use? Well, what's this one? I was saying less than or equal to 0 because it's all below 0. So then this one is? No, the opposite of that, because isn't 2 the lowest point? 2 is the lowest point of the parabola. That means that all your y values, all the y values on the parabola are above it. So it's got to be y is greater than or equal to 2. You can't say equal to 2. You have to tell me that they're always above 2. Or you have to tell me they're always below 0. Are you sure? Okay. So that's properties of graph parabolas. Okay, that takes care of the first quiz. But what was the other way that I said that parabolas can be expressed? Other than a graph, how else can we express parabolas? Sorry? Yes, in an equation. Good job. So, there are three main equation types. There is standard form. Standard form is y is equal to ax squared plus bx plus c, where a, b, and c are numbers. The y and the x are going to be there. Then there are two more after that. There's factored form. Factored form is, or would you, based on how you wrote this on your page, would you rather me write it down here and up here, or right here and? Okay, so I'll go factored form. You can write it whatever way you want. Factored form is, but I'm going to write up here too, the other one, which is vertex form. So factored form is y is equal to a x minus r x minus s, where in this case, the numbers are a, r, and s. Here the numbers are a, b, and c. And then in vertex form, it has another set. It's y is equal to a x minus h squared plus k, where a, h, and k are your numbers. Okay? How do you know that something's in standard form? Well, there are no brackets. It's expanded and simplified. How do you know that it's in vertex form? It has only one x. This is the big way to tell whether it's in vertex form or not, because it only has one x. Okay? Now I'm going to give you the equations to these. This equation is y is equal to negative x plus 3 squared plus 1. That's the equation of this parabola. This parabola, the red one, is y is equal to 2 x minus 2 squared plus 2. And this blue one is y is equal to negative x minus 4 squared. These are what they are in vertex form. Okay? What does it look like the A is from this? I'm going to get another color. Excuse me. What does it look like the A is from this? Ready, Jules? If this is vertex form, what number it looks like is in the place of A? Very good. A is equal to negative 1 here. Katie, what does it look like the number is in for H? Yes, it's negative 3, because if you put 3 in there, then you would have x minus 3. You need to have a negative 3 to cancel out, make it positive. Basically, what you have to remember is the opposite of what you see. Okay, so H is actually positive 3. K is equal to what, Nick?
1.
Yes. For this equation, what does it look like A is? Maya? Okay, Nick, negative 1. Maya, what does it look like H is in this case? Good, it's the opposite. Jules, what does it look like K is? If you had a 1 here, it would say +1. It's 0. In this case, K is 0. Nope, it's always the opposite. Your H is always the opposite.
Yeah, but that's positive 3, not negative 3.
The vertex is -3.
Oh, yeah, I don't know why I said that. Thanks, guys. I think I said -3, but then I wrote +3. Sorry, guys, thank you. Good job, Nick. And then here, what is the A value here? Yeah, good, always going with the A's here. What's the H value, Maya? Good. And what's the K value, Jules? Good. So let's talk about vertex form. How can you tell what your vertex is? Compare the H or the A, H, and K values from this. Compare that to the vertex. How can you tell what the vertex is? I'll let you think, don't answer yet. So how do you think you know what the vertex is? Yeah. Yeah, very good. It's the H and the K. Notice that no matter what the H is and the K is, that's always your vertex. 4, 0 here, and then 2, 2. Okay? You cannot tell what the x-intercepts are from vertex form. Vertex form is good for finding the vertex, but it is not good for finding x-intercepts. So for this, you're going to say x-intercepts, you have to set y equal to 0 and solve. It's not an easy process. We'll talk about that later, though. The direction of opening. How can you tell what the direction of opening is? Yeah. Yes. So direction of opening is up or down based on if A is what? Jules, if A is? Right. So if it's up, if A is positive, which how do we positive in math? We say it's greater than 0. Because bigger than 0 means you're positive. And down if A is negative. So if A is less than 0. What does it look like the max or the min value is? Which one is it? Where do you find your max or your min value? Say Katie. So look at the max or min value here, Katie. And tell me how you can tell from the A, H, and K what. So look at the max value or min value, what each of them are, and compare them to the A, H, and K from, like which one is giving you the max or min value?
Max is K, and min is H.
No, it's always K. It's always K. Okay? The way you can tell if it's a max or a min is based on the direction of opening. If it opens up, do you have a max or do you have a min, Katie?
Up is min.
Okay. If If you open down, you have a max. So max of, it's always k for max or min, but it's a max of k if it opens down, and it's a min of k if it opens up. The axis of symmetry. The axis of symmetry always takes the form what? What do you always have to write, Maya, when you write an axis of symmetry? Yes, x is equal to. Now, what letter is the? It is the h. Since your domain is always x belongs to a set of real numbers no matter what, so domain is x belongs to a set of real numbers, the range is, it changes. It's y belongs to a set of real numbers such that y is, what value does it seem to be taking the range from? The AH or K? So look at the range and tell me, is it the AH or K, Jules? Okay, what value is here? Okay, is that the AH or K? Okay, here, is it the AH or K? Right, it's always the K. So the range is going to be either greater than or equal to K or less than or equal to K. It's one of the two. It's always based on K. But how can you tell when it's greater than or equal to K? How do you know when it's going to be greater than or equal to K? Nick? How do you know that the range is going to be greater than or equal to K? If what's positive or negative? So this has a K of 0, so that's not positive or negative. So it doesn't really tell you whether it's greater than or less than. So how would you know? Which ones are less than and which ones are greater than? Which one is less than and which one is greater than?
Less than is the arrow that way.
So is this less than or is this?
That's less than.
Okay, is this one?
Less than.
And this one is?
Greater than.
Okay, so these two are less than and these two are greater than. What's in common about what makes sure that they have that they're either less than or equal to this number, the K, or greater than or equal to? What's the significance? How can you tell? No, because the vertex doesn't tell you whether it's less than or greater than. This is saying that it's always below 1. This is saying that it's always below 0. This one is saying that it's above 2.
So whatever it is, say if it's like y greater than 3, it's always going to be above 3. And then
How do you know whether it's going to be above or below? Why are these ones below and why are these ones above 2?
because of the max and minimum value.
Yes, and you're right. It's the max or minimum value. These have max values. Why do they have max values, though?
Because they're max if it's down.
If it opens, so yes, very good. Yeah, very good. It changes it based on the direction of opening. Yeah, good. So this one is greater than, this one's less than because less than looks like an L. Greater than means it's opening up or opening down? For greater than.
It's greater than it's opening up.
Yes. And this is if it opens down. Okay? Good. So that's how you can tell if it's vertex form. That is the second quiz. The next quiz is if you have factored form. So which, just tell me when I can erase. Can I erase this? Okay, no worries. I'll just write the equations. Okay. So if we have factored form is going to look like y is equal to a x minus r x minus s, where a, r, and s are different numbers. So a, r, and s are different numbers. How can you tell what the x-intercepts are? Yes. Yes. Your x-intercepts are r0 and s0. Remember that when it's in the brackets like this, the r and s is the opposite. So right, Jules and Katie, look at here. See how this is +2 and +4? That means their x-intercepts are, oops, this is -4. Okay, so -2 and -4. The next thing you find when you're in factored form is you find the axis of symmetry. The axis of symmetry is, what you do is, you remember?
Oh, yeah.
Yeah, what is it?
It's r plus s divided by 2.
Yes, very good. It's r plus s divided by 2. What you do is, the axis of symmetry is always halfway in between. So if, like I said, oh, you got 50 on this test, and you got 70 on another test, how would you know what halfway or the average is? You add, divide by 2. So that's the same thing here. If you take your x-intercepts, you can find that midpoint, or that middle line, by adding them and divide by 2. Be careful when you type this into your calculator. You have to use the fraction button on the good calculators, okay? Because you can't just divide by 2. You have to first add, then divide by 2, okay? Next is the max or min value. To find the max or min value, you have to substitute the axis of symmetry into the equation for x. So you have to take that value. Remember, the point of an equation is to find different y values when you know an x value, or vice versa. So if you know, like, what's the axis of symmetry for this one? So this is -2, this is -4. So what's halfway in between -2 and -4, Jules? Careful. halfway between -2 and -4. Yeah, left side matters, right? So is -3. So what you do is you sub to figure out what this y value was, because say you didn't have a graph. You take -3 and you sub it into here. So if I sub in -3 in here, this is what it would look like. It'd be y is equal to -1 still out front, -3 plus 2, -3 plus 4. What's -3 plus 2, Nick? Good. So I still have the -1 out front. I have a -1 here. And then Katie, what's -3 plus 4? Good. This should always happen where these numbers are opposites of each other. You're in a bad place or you're off track if that doesn't happen. Okay? When you multiply all those numbers together, what do you get, Maya? -1 times -1 times 1? I'll go to you, my calculator girl. Yeah, very good. Very good. Loves that calculator. Remember our first sessions? So yeah, that's why the 1 is the max or min value, right? If you would have subbed in and gotten 2, the problem must have gone up to 2, okay? And then your vertex for this then, your vertex is always your axis of symmetry and your max or min value. Those are related. Direction of opening is always easy, so I'm not going to write that. And then for the domain, it's always x belongs to a set of real numbers. The only difference is for the range, it changes based on the y value, or the max or min value. It's always greater than or equal to the min if it has a min, or it's less than or equal to the max. Okay? That'll take you a couple quiz, or that'll cover quiz 4. Okay. Now that we know those properties, let's graph parabolas. So graphing. There are 2 ways that we'll graph. You either have to use vertex and step pattern, or you use the x-intercepts and vertex. You do this one for vertex form, and you do this one for factored form. The step pattern is 1, 3, 5. Okay, we're going to use a 1, 3, 5 step pattern instead of 1, 1, 2, 4 step pattern. That's your step pattern. Okay, so let me give you an example. What if I said, here's my pen, to graph y is equal to -2 x minus 1 squared plus, let's say 6. What you use is the vertex. So look onto your page from before. Nick, what's the vertex? How can you tell by looking at this what the vertex is? Nope. It's close. Okay. Got it? Yeah, you have to get that down, okay? So, yeah, it's HK, which is 1, 6. Remember that H is always the opposite, okay? And your step pattern, I forgot to write an A out front of this, I'm sorry. It's A135, so what's the A value in this? So step pattern. Jules, what's the A of this? -2. So it's going to be so it's -2 times 135. Multiply those for me, Katie. -2 times 1 is? And then? Yeah? Good. So how you graph this is you go to, I lost you?
No, no.
Okay. What you do is you plot the vertex. I'll let you catch up. Bring your heads up when you're ready. Good? Okay. So Maya, where's 1, 6? Which quadrant? This one, this one, this one, or this one? Yeah, quadrant 1, the top right. So 1, 6, right? So 1, 2, 3, 4, 5, 6. Then, from there, I realized that I forgot to tell you guys how to find a y-intercept, sorry, from vertex form and factor form. To find a y-intercept, you always set x equal to 0. Y-intercept. You gotta set x equal to 0. Yeah, sorry. Okay, so now that you have, we'll come back to this. I'll do an example with it. So, the vertex, right? Then you use the step pattern. So the step pattern is -2, -6, -10. From the vertex, you go left 1, down 2. So it's now here. Then you go left 1, another, you step to the right, or step to the left 1, then go down 6. So now it's here. So you go back, you start at the vertex, I can't talk right now. You go over and down 2, then over 1 and down 6. Then you do the same thing on the right because parabolas should be symmetrical. So you go to the right 1 and down 6, and you go to the right 1 and down 2, and then you go to the right 1 and down 6. The 10 is not necessary because it would be way off the page. Yeah. So this is your vertical step pattern. It's how much you walk up and down. You always go over 1. So you start at the vertex and you go over 1 and down 2. Over 1 and down 6. Over 1 and down 10, but 10's way off the page, so we won't do it. Then you go back to the vertex and do the same thing to the right. Okay? So it gives you this skinny parabola. Okay. On your test, make sure to label this. Y is equal to 2 squared plus. I don't so much care about numbers here, as long as they're actually by ones. I don't need the numbers there, and I don't care so much about axes labels like y and x. It's all stuff now that's pretty obvious to us. Back in grade 9, we probably would have. Okay, so that's how you graph if you have something in vertex form. That's definitely the easiest way to graph. The other way is to use vertex and step pattern. So if I get, or intercepts, it's to use x-intercepts in the vertex, and that's if you have something in factored form. For example, what if I had 1/2 x minus 4 and x plus 2? That's in factored form. The first thing I do is I find my x-intercepts. So go ahead, Jules, and look on the other page and tell me what your x-intercepts are. Yes, you were the one who answered that when I asked the question last time. That's why I gave it back to you. So yes, what is the RNS in this case? Careful. What do you got to remember? Very good. 4 comma what? Very good. And?
2. Yeah, 0, 2 and 0. Negative 2, 0.
Right, don't forget that. Okay, vertex. Katie, you answered this last time. How do you find the vertex? Well, we look affirmative when I explained it last time. Sorry, I can't talk right now. Axis of symmetry. Axis of symmetry. How do you find, what's the formula for axis of symmetry? Nope. Because we're not dealing with something in vertex form. We have factored form. There was a formula for it. Maya is the one who answered it. You were the one who agreed. And you can go back to your page. You just learned it, so it's fine. What form are we in? What form are we in? What equation form are we in? No. Look at factored form has brackets like this. So it's r plus s divided by 2. What is r? Nick? What's r? Good. So 4 plus negative 2 divided by 2. What did I say to do when you type this in your calculator? Yes. Good. Answer? Yes, it's 1. So x is equal to 1 is your axis of symmetry. What is your, does this have a max or does this have a min value? Katie? Look at this equation, and does it have a max or a min? Sorry? It has a min. It is a min value of, now, what did I say, Maya, on how you find the min value? What? How do I know what the min value is? There's a process. Go ahead and check on the page. I asked Maya that question, so she's going to look up. It's on your page. You tell me, how do you know if it's a min value? Based on the, how do you know if something's a min or a max? Are we dead? Okay, it's based on the direction, I've got to hurry up here. So it's based on the direction of opening. So is this opening up or down?
Oh, it's opening up.
Right. So then that's why it has a min value, because if you open up, you have a lowest point.
Oh, okay.
Okay? So min value, what you do is, what's the process?
Oh, you substitute,
Yeah. Substitute what?
substitute the axis of symmetry in 4x.
Yes, so you go y is equal to 1/2, 1 minus 4, 1 plus 2. What did I say would happen here?
You should get all the same numbers.
Not all, just these two. Same numbers, but different signs. 1 minus 4 is -3. 1 plus 2 is 3 times 1/2. You end up getting -9/2, which is about 4.5, -4.5. How are we doing? So what's your vertex then for this? Yes.
It's 1
What's your min value? -4.5. -9/2. You'd have to write -9/2 in your notes. Yes.
What is the sign next to -4.5?
Approximately, sorry.
Oh,
Yeah, it's like,
yeah.
oh, it's actually not even approximately, because you can put an equal there. Because I didn't round there. So, now you can graph this. You can go to -2, plot a dot. -2, 0, plot a dot. You can go to 4, plot a dot. Then you can go to 1 and -4.5. So that's about here. There's your parabola. So you've got the ordered pair -2, 0, 4, 0, and the vertex of 1, 9/2. Okay, let's stop there, Nick. Testing, 1, 2, 3. So let's do modeling quadratic functions. Modeling means that you're going to find the equation of the function. I'm going to give you information, so instead of me giving you the equation and then you graphing it or telling me the properties, I'm going to give you the properties or give you a graph and then you're going to model it. You're going to give me the equation, sorry. So I'm going to either give you a graph or I'm going to give you information and you're going to go and find me the equation. For example, find the equation of a parabola that has a vertex of 3, -2, and passes through, so passes through, let's go 1, let's go 1, -3. Actually, we'll change it to -4. That'll be a little bit nicer. So then here's what we know. We know that it passes through a vertex. It has a vertex of 3, -2, but it also passes through the point 1, -4. Sorry, 3, -2 is down here. It also passes through 1, -4. Okay? So we know that the parabola is going to look somewhat like this. We want to find that equation. There are two main equation forms that we work with. This will be on your presentation for Unit 2. Okay? We're in our conversation. So there are two main forms. What are the main forms and what are they good for? So what are the two forms you learned other than standard form? Nick, name me one. There's factored form and the other one is? Right. Jules, which one is vertex form good for? What is it good for finding? What about the parabola? What does it tell you right away? Yes, vertex form is good for vertex. Factored form is good for telling you what? Yes, the roots are the x-intercepts. Very good. Roots mean the same thing as x-intercept. Also the word zeros. Good job, Maya. So, sorry? Because I know that it's 3, negative 2. I know that cap. Okay, that wasn't important. It wasn't really important. More is the fact that, do you think we should be using vertex form here? Think that we should be using factored form. Katie? What is vertex form good for, and what is factored form good for? What did we just say? And factored form is good for finding, or what else are those called? What is roots? It's the x-intercepts. She said the word roots. We haven't been using the word roots, but roots is x-intercepts. So repeat back to me what we said. What is? Tell me everything that I just said. Good. So which one should we be using in this equation? Should we be trying to put it into vertex form, or should we try to put it into? Because? Yes. So you start by going y is equal to a x minus h squared plus k. Where do the numbers go in here, Jules? What numbers do we always fill in? Not just the h and the k. We also fill in what number? Yes, we always put in a value for a as well. The vertex tells us what, Maya?
The vertex tells us where the maximum is.
Yes, but out of those values, what does it tell us? The fact that our vertex is 3, negative 2, it helps us to fill in some of this vertex form.
The h and the k.
Right. Am I going to put here, Katie, am I going to put x minus, what number am I going to put here? Tell me what to write.
On the h?
Yeah.
Oh, like x minus x minus negative 2.
What is the vertex? Look on your note. What's your vertex?
H and k. So x minus.
Take that in. Make sure you don't forget that. Okay. So it's x. H is what number here?
H is the.
What is h and k? Go ahead.
Oh, sorry. The vertex. Wait. The vertex is h and k, so it's like the h is the negative 2.
But if it's h and k, then why are you saying that h is negative 2?
H is the first.
Yes.
No, yeah, h is the first number 3.
Okay.
K is negative 2.
So then I should be putting h minus 3 squared minus 2 here.
Right.
Take that in. Don't forget that, please. What I don't have is the a value. Okay? I don't have the a value. Do you understand the problem, Julia? That to find the equation, I need to fill in for a, h, and k. Nick, stay off your phone. You need to fill in a, h, and k. I do not have anything for a yet. But what piece of information have I not used yet, Nick? You have not used the fact that this passes through the point 1, negative 4. But equations should always satisfy every ordered pair if you sub it in. So what you do is you sub this into here. What am I going to put in for y, Katie?
1. Oh, no, negative 4.
Because which one's the x and which one's the y? This is x and this is y. So you put in negative 4 here. Start to solve for me? Yeah. Okay. Did you have a question?
No.
Okay, so by bedmass, Jules, what should we do first? Yes. What do you get inside the brackets? 1 minus 3, which is? Good. So we get this. Then what do we do by bedmass? Yes. So what's negative 2 squared? What's negative 2 times negative 2?
Oh, positive 4.
Okay.
Wait, why is it using that?
That squared on this is, this squared means negative 2 times negative 2. This, instead of writing A4, we don't write that in math, we write 4A. So it should be 4A minus 2. What's the goal here, Nick? To get the A by itself. Maya, what would I do first to get the A by itself?
Bring over the -2.
It makes it what on the left?
-6.
Careful, because when this goes over there, what does it become? So we have negative 4 plus 2 equals? Yes. What is left on the right side?
4A.
Good. Jules, what do I do next? Divide by 4 on both sides. What's the answer to this? Don't say negative 2. Katie, what's the answer to this?
Just 2.
No. Negative 2 over 4. It's a fraction. What do you do with fraction? Yes, you reduce. So what's the answer? What's the answer to this? Negative 1 over 2. So what's my final answer to this? Julia, what was the goal? Why were we doing all this again? Yes, because we have to find the equation. So now, based on this, you can tell me y is equal to negative 1/2 x minus 3 squared minus 2. That's the equation of that parabola. That's what modeling is. It's to go and use the information that it gives you to go and create the equation. Instead of me giving you the equation and you telling me this information. Got it? Let's do another one. Here's a parabola. I want you to find the equation of this parabola. What are we given here? What are we looking for, Jules, in this? Or sorry, if you guys are still copying, where are you at? You here? Can I erase?
Yeah, you can erase it.
Maya, can I erase? Okay. All right, Jules. I'm looking for one of two things when I'm modeling. What are they? What are the two things that, one of the two things that I'm looking for? Not yet. Not yet. What do I start to try and find? To see whether it has something or something else. Vertex or? Is it giving me the vertex or is it giving me, what's the other thing it could give me? The x-intercepts. Very good. Is this one giving me the vertex or the x-intercepts? Good. So the vertex is what, Jules? Good. You finally got your 3 that you've been wanting for so long. So 3, negative 3. So that tells me right away what?
I just have a question.
Yeah, sure.
They're just, like, vertex and x-intercepts are the two things that we're always trying to find in the model?
Well, yeah, because if it's vertex, then we use vertex form, but if it's x-intercepts, then we use factored form. So that's what you want to aim for. Good active learning. All right, so Nick, what does this tell me right off the bat? The fact that I have a vertex and I'm trying to come up with the equation, what does it give me right off the bat? Good. So tell me what to write for starting the equation. Because I don't know it yet. Katie, is this enough? Is this a good enough equation?
No.
Why?
The seven, H and K.
What? You already subbed in the H and the K.
It writes out.
So we need to find A. That's the problem, is that we don't know A. But you cannot use another point you have to use a different point that we know. So what's another point on the parabola that we know it crosses?
The 1 and 0 and
1, 0 is here.
oh, the 0 1, sorry.
0, 1 is here.
0, -1.
Okay, you're gonna get that wrong if you pick the wrong point. So you get 0, -1. Maya, ready, go. Ready, 7.
Oh, -1 equals A bracket 0 minus 3 bracket squared minus,
Minus.
oh, 3.
Okay. Jules, go. Next. Katie, you're next, so get ready. Nick, you're after that.
Like, solve it?
Yep, start.
Okay, so 0 minus 3
Okay.
is,
Tell me what to write, left to right.
A, and then 3,
No.
-3
Thanks.
squared minus 3.
Good. Katie.
-1 was -6,
Careful.
just 6A.
No. What's -3 squared mean?
-3 times 83.
Which is?
-9, or 9.
9. How do I want you to write this?
9.
9A. Ready?
-3.
Good. Nick, finish off.
Move the 3 over, make it -2 minus 1.
Good. Which is?
2.
Good. Then you.
Then you write 9A,
Okay.
and then divide by 9A.
Good.
9,
Good.
which will give you 2 over 9.
Good. What do I have to finish off with, Maya?
Oh, you have to sum it back into the
Give it to me.
y equals 2 over 9 bracket x minus 3 squared minus 3.
Good. Good job, guys. Last one. Not the most symmetrical parabola, but heads up when you're ready. Everyone. What am I going to ask first?
I'm going to ask what equation you should use,
Yeah, based on. Very good. Based on.
the information that we are given,
So what one?
the x-intercepts,
Good. Remember, Katie, what are the two things that we look for?
vertex and x-intercept.
And this one gives us the.
The x-intercept.
So which form should we use?
Factor form.
What is factored form?
Y equals A bracket x minus r bracket x minus r.
Very good. Nick, what do I write next? A. No. What? Thanks, fam.
What was the point?
We're almost done this, so just wait, guys.
So you write x minus 5
Good.
yeah,
What?
plus 5
X plus 5. And?
x plus minus 3.
Yes. What are the x-intercepts, Jules, from this?
0 and negative.
Guys, got to be careful with your order. That's going to be a huge problem.
Oh, sorry. -5 and 0.
Good.
-3.
negative 3 zeros over here. Jules, you gotta get these ordered pairs. Let's go. 3, 0, and why does it say plus 5 and minus 3 here? It's the opposite. Good. So now we have this. Are we done? Katie, are we done?
No.
Why?
We need to solve it for A.
Yes, we need to find A. Very good. So what other thing are we going to use, Nick, to find A? We don't fix it. It's not clear. One point in this parabola that's really clear that it crosses through. Very good. What's that y-intercept? What's this ordered pair? Y'all are killing me with these damn ordered pairs.
0, -4.
Thanks. Holy hell. 0, -4. Ready, go, Nick.
With the -4
Okay.
equals 0.
Whoa. Aren't we trying to figure out what A is?
Oh, sorry. A, 0 plus 5,
Okay.
bracket, and then 0 minus 3.
Good. What do you need to see? You say you can't see something?
Yeah, no, I can't see.
You can't see the board? Why? Well, yeah. How long have you been able to see the board? One, why didn't you bring your glasses? But then two, like you can sit forward.
It's okay. I've gone this entire time now.
Okay, well, ready. Here we go. Jules, what do I do first in here? It says 0 plus 5, 0 minus 3, -4 equals A.
So -4 equals
Yes.
A, and then it would be positive 5, and then positive, and then -3.
Good. Now what do I do?
Oh, multiply.
Okay, what do I write?
-15. 15A.
Thank you. Very good. Pay attention here. When you write this, you have to write -15A here. Don't write A minus 15. Then you're going to think that you have to add it across. Okay? You need to have -15A because that's something that will trigger in your head what you're supposed to do next, which is what, Katie?
Like
Divide by -15, so I get A equals 4 over 15, meaning my final answer on this is y is equal to 4 over 15, x plus 5, x minus 3. That's how you model equations. Okay, let's stop.